Hey guys, this is Mr. Piercy, and what we're going to be looking at in this video lesson is properties of three-dimensional objects, identifying what is a polyhedron and what is not a polyhedron, and looking at some of the characteristics of what a polyhedron is. So a polyhedron is essentially a three-dimensional shape that's made up of nothing but polygons. Uh, the parts of the polyhedron are going to be referred to by different names. So here in the picture on the left with the prism, you can see that it's made, first of all, it's a polyhedron because it's made up of nothing but polygons, and where the each polygon is referred to as a face, where the faces intersect each other, they make an edge. That line segment is referred to as an edge, and where the three or more of those line segments meet, that's referred to as the vertex. So uh, what we will see here is that we definitely have lots of things that are three-dimensional, but they're not going to be polyhedrons. So we have here examples of three-dimensional objects that are not polyhedrons. Anything that has a curved surface to it will not be considered a polyhedron. So go ahead and take whatever time that you need to copy down the definitions here. But one of the things that I want to make very clear, polyhedrons, one of the things that we definitely talk about when we look at three-dimensional objects are pyramids, prisms, cylinders, and cones. And you're going to be hearing the term base used a lot when we talk about those things. Well, base has a tendency, the vernacular, the word base makes people think that it has to be at the bottom of an object, but it doesn't have to be. For instance, here I have two prisms in the picture where on the left is a triangular prism and the base of the prism is the triangles, not the rectangle that's at the bottom. The bases of the prism on the right are octagons. What makes a polygon the base of a shape is the fact in a prism it's going to be two polygons who are parallel to each other and congruent to each other. For a prism, I'm sorry, for a pyramid, it's just going to be whatever shape is at the is whatever shape is generally not necessarily a triangle, but it's going to be the one shape that's not going to meet the other faces at a vertex. That's kind of the best way I can explain it. Um, so for instance, we could have like a square like this, okay? Well, the face that's at the bottom, the face that's here that I'm going to consider the base is going to be that quadrilateral at the bottom. That's going to be the one face that won't meet the other faces at a vertex, like what we have here. Moving on for the rest of the vocabulary on this page, we have regular polyhedron. Regular polyhedron are simply polyhedron that are made up of nothing but regular polygons. They're also referred to as Platonic solids. So in the definition at the bottom and on the image on the left are things of what regular polygon or regular polyhedrons are. Regular tetrahedron, cube, octahedron, dodecahedron, and isosahedron. It is possible to have polyhedrons that are also tetrahedrons or octahedrons or dodecahedrons, but they won't necessarily be made up of regular or of regular polygons. So only the Platonic solids that are made up of regular polyhedrons are called Platonic solids. I mean, there's kind of back and forth with what a regular polyhedron is and what a Platonic solid are. It is possible to have, again, other three-dimensional objects, other polyhedrons that are, for instance, an isosahedron, but they may not be made up of regular polygons, so it would not be considered a Platonic solid. Concave polyhedron, kind of like a polygon in and of itself. We can have a polygon, convex and concave. For instance, concave or convex would be like where we have kind of a pentagon like that, where if I go from corner to corner, I can kind of draw all the diagonals in, and they don't really cover, or they don't go to the exterior part of the polygon. Whereas if I were to, say, take a polygon like this, when I connect those diagonals, I'm going to pick another color for the diagonals. When I connect those diagonals here, here, and I'd have, like those there. But when I connect the diagonal here, one of the diagonals is outside of the polygon. That's what the difference between a convex and a concave polygon is. Essentially, part of it goes to the interior portion of the figure, and that's the same thing with a polyhedron. So over here on the left, we have a convex polyhedron and a concave polyhedron, and the difference between them is that part of the uh, part of the concave figure will be facing towards the interior of the figure. And the last thing that we're looking at here is the cross sections. So a cross section is whenever I take a solid, whatever that solid is, and I slice it with a plane, or a plane intersects it. Well, kind of think about slicing an orange in half. Well, so an orange you can basically think of as a cylinder. When you cut it in half and you hold the and you hold the halves, if I could get it out, uh, where you're looking at, where you sliced it, where the meat of the fruit is, they look like circles. So that would be the cross section. So the plane is the knife that's slicing through the cylinder of the sphere of the orange. So on the left here we have a cone that has four planes intersecting it, where I have, depending on how I slice it, I can make a circle, an ellipse, a parabola, or a hyperbola, depending on how we slice it. And they can change depending on whatever figure that we're, whatever polyhedron or three-dimensional object that we're looking at is. So here's just more examples of examples and non-examples of what polyhedron are. Remember, a polyhedron has to be made up of nothing but polygons, and any three-dimensional object that has any kind of curved surface to it is not going to be considered a polyhedron. So here are these polyhedrons, and if so, identify how many faces, vertices, and edges that they have. So the first one on the left, figure A, that is a polyhedron because it's made up of nothing but polygons. It has four faces, so that is going to be called a tetrahedron. It also has four vertices, and here we're going to have six edges. Figure B, that also is a polyhedron because it's made up of nothing but polygons. The bases are hexagons, so here we would name this to be a hexagonal prism or a hexagonal prism, depending on, depending on the region of the country that you may be from, the emphasis on the A, hexagonal or hexagonal, depending on how, they're both fine, tomato, tomato, but here we're going to have 8 faces, it's going to have 12 vertices, and 18 edges. The last one, you might have sheds in your backyard that look kind of something like figure C does, but that one's not going to be a polyhedron because it does have a curved surface at the top. It has kind of half of a cylinder sitting on top of a prism, so that one's not going to be a polyhedron. Now, polyhedrons, a second ago we were talking about how many faces, how many vertices, and how many edges the object has. Well, one of the things that we do use in geometry, it's not really used a lot in geometry, and uh, you'll probably never see it again outside of geometry, but there is a little theorem that we use here. This is pronounced Euler's theorem, not Euler, but Euler's theorem. If the number of faces and the number of vertices will be equal to the number of edges plus 2. So we have this little equation that we use to find, like if I know how many faces there are and then know how many edges there are, I can calculate how many vertices there will be in an object. Personally, I think of it as the acronym of 5 plus 2. That's how I always remember how to write this equation, as 5 plus 2 with the equal sign in between them. That's just how I think of it. But a little bit about who it's named after. It's named after this Swiss mathematician named Leonhard Euler, who was a big time brain. He was a very prodigious mathematician and scientist who wrote all kinds of papers. I think at the bottom here it says something he wrote, yeah, 800 papers in his lifetime. But he had such a prodigious memory that he eventually lost sight in both of his eyes and was still able to publish papers on math and science simply based on his uh, powerful brain. I don't want to say like he had a photographic memory. I think they refer to it more of as like an eidetic memory or something like that, but somebody who's able to remember in great detail things that they've experienced. It says at the bottom there that he won something called the Paris Academy Prize 12 times. The Paris Academy Prize is still kind of going on today. It's gone through several versions of itself. But the Paris Academy is something that was founded by mathematicians, scientists, and philosophers uh, that would talk math, science, and philosophy, and kind of encourage growth and try to bring renown to their field of study. But anyway, moving on, that's how we're going to use Euler's theorem. Euler's theorem, here we have, this is an irregular polygon, but the bases, you can look at it here, the base of the prism has 6 sides, so this is a hexagonal prism or a hexagonal prism, however you want to say it, where the 2 bases are those irregular hexagons there. So we want to know how many of what part does it have? Well, here, the way that we know this, this is just a way of checking Euler's theorem. It has 8 faces, has 12 vertices, and 18 edges. So if I substitute those values into that 5 plus 2 Euler's theorem formula, F plus V equals E plus 2, here we can see when we simplify them, they match, they balance, which is what works for every polyhedron, and it works for really the big ones too. When those regular solids, the platonic solids that we had, the isosahedrons, those things get crazy with the number of faces, vertices, and edges that they have. But that simple little formula really works for all of them. So if I really need to know faces, vertices, and edges, I can use that to help me figure them out. So here we're looking at some three. Come on, Mr. Pierce, you get it together. So here we have three three-dimensional objects. We have a sphere, we have a pyramid, and we have a cylinder. Now, we're not really looking about are they polyhedrons or not. Here we're just looking to see what is the cross-sectional shape that's formed when I intersect the solid with the plane. So in figure A, when we intersect the sphere with the plane, the way it's being sliced, we're getting a circle. Now, depending on how the plane is being intersected into the figure, here we could get a oval or an ellipse. We might be able to get a hyperbola or a parabola out of it. But the one next to it, the prism, it's a pentagonal or a pentagonal prism, depending on how you want to say it. Again, it's just mostly they're kind of doing it horizontally. So here, that cross section is also a pentagon. And when they're slicing the cylinder with the plane, you can see the shaded area there that's making a rectangle. So here we're just kind of identifying what shapes are made with the cross-sectional areas. So at this point here, guys, go ahead and pause the video and answer these 3 questions. Tell me whether or not they're polyhedra, and if they are, name them. What type of polyhedron is it? And then identify how many faces, vertices, and edges it has. So go ahead and answer these 3 questions, and when you're done, come back and hit play and compare your answers with mine. Okay, so hopefully we have some good answers here. Again, when you're answering something like this, This isn't really just a yes or no question. We want to have some reason why. So please, hopefully your answers are in the form of some kind of a sentence and not just like a sentence fragment or just a simple word. So is this a polyhedron? In this case, yes, it's a polyhedron because it's made up of nothing but polygons. In this case, the bases are pentagons, so this is a pentagonal prism. And so that means that there are 7 faces, 10 vertices, and 15 edges. Figure number 2 is a cylinder because it has a curved surface. It's not going to be a polyhedron. And the last one at the bottom is going to be a rectangular pyramid. It's made up of nothing but polygons, so it is a polyhedron, and that gives us 5 faces, 5 vertices, and 8 edges. And here again, go ahead and for these next 4 problems, go ahead and just pause the video and quickly answer these 4 questions. When you're done, hit play and see what I have for my answers in comparison to yours. All right, so hopefully we have our answers worked out here. Is it possible for a polyhedron to have 16 faces, 34 vertices, and 50 edges? Yes, no, or why? And so here, no. According to Euler's theorem, if I substitute those values into Euler's equation, it does not balance. So it is not possible to have a polyhedron with 16 faces, 34 vertices, and 50 edges. What type of shape is made from the cross-section of the cross-sectional shape is made when I intersect the solid with a plane. In this case here, we get a rectangle, and the next one we get a pentagon, and somewhere, there we go, pentagon, and the last one is a triangle. So that brings us to the end of this lesson. Remember, we're talking about what a polyhedron is. A polyhedron has to be made up of is a three-dimensional shape made up of nothing but polygons. You can have convex and can have concave polyhedrons depending on how it's constructed. And Euler's theorem can be used to help us determine how many faces, vertices, or edges it has. It's just another equation, so if I give you 2 to 3 variables, you should be able to find what the missing one is and identify what the cross-sectional shape is when plane intersects the solid. But if you have any questions about anything that we've covered in this lesson, or if you just have any other questions about polyhedrons themselves, by all means, let me know what they are. Email me, send me a message, some way, somehow, come see me in class. But until next time, ladies and gentlemen, thanks for watching and take care.